This is a weekly summary of interesting news that is relevant for my lectures at the Eastern University of Applied Sciences in Switzerland. My name is Thomas Bocek, and today we will discuss 5 topics. The first topic is about supply chain attacks. It's the following article here, and early this month, attackers compromised a package maintainer's account through a phishing email that appeared to come from NPM support. And the fake email warned that accounts would be locked and directed users to update their two-factor authentication on a fraudulent website that stole their login credentials. And after taking control, the attacker injected malicious code into 18 popular NPM packages, including the following ones here. And these packages were downloaded over 2.6 billion times per week and are used across countless web applications. And the malware specifically targets cryptocurrency transactions, and when users visit websites built with these compromised packages, the malicious code runs in their browser and monitors for crypto wallet addresses and transactions. It then redirects payments to attacker-controlled wallet addresses instead of the intended recipient. The code hooks into JavaScript functions and wallet API to intercept Bitcoin, Ethereum, Solana, and other cryptocurrency transfers. The attack window was short, only when installed between 9 and 11:30 in the morning on the attack day. These installs were affected, and only if they created a new package log file during that period. NPM has since removed the malicious package versions. And this incident shows how distributed package management system create single points of failure where one compromised maintainer account can affect millions of downstream libraries and applications. Being aware of your development environment and its dependencies is critical, since these supply chain attacks can directly target the crypto functionality your application relies on. The second topic we also covered in our distributed systems lecture. It's about performance. Many students use Docker with Windows Subsystem for Linux version 2, which allows developers to run Linux applications inside Windows. Recent testing by Phoronix, it's the following site here, compared Ubuntu 24.04 running Windows Subsystem for Linux, in short WSL2, versus the same Ubuntu version installed directly on hardware without Windows. And they tested it on a recent machine. And the interesting part is then here in the performance. So overall, WSL2 delivered 87% of bare metal Ubuntu performance across more than 50 different benchmarks. And here we see the benchmarks. We see on the pinkish side here the bare metal, and on green we see if Windows 11 with WSLT is faster. And here for HTTP server for Postgres, we see a massive win for the bare metal. And we also have some tests, interestingly, for the WSL2 versions. And the largest performance gaps compared in input-output incentives task. Database operations like SQLite showed major slowdown on the WSL2. PostgreSQL and web servers like Apache and Nginx also performed much worse when running through the Windows subsystem layer. And code compilation showed mixed results. Smaller projects had minimal performance differences, but larger code bases with heavy disk access like LLVM took longer to build under WSL2. And the extra overhead added several seconds to compile time. And some applications actually run faster in WSL2 than on bare metal Ubuntu. Python scripts, PHP applications, and OpenSSL encryption all showed better performance when running through Windows. And this appears to relate it to how Windows handles CPU frequency scaling and power management compared to Linux. For developers requiring to use Windows but needing Linux tools, WSL2 provides acceptable performance for local development and testing. The convenience of not running a full virtual machine makes it practical for most development workflows, though production workloads would see better performance on native Linux systems. The next topic is about Swissborg that was hacked and around 41 million US dollar in Solana tokens were stolen from the Solana chain. Well, it's a bit more complicated as Swissborg itself was not hacked. Swissborg lost 41 million in Solana tokens through their staking partner Killin's compromised API, and the attackers didn't breach Swissborg's system directly, but exploited vulnerabilities in their trusted third-party provider. 8 days before the attack, hackers made a routine-looking on-staking transaction worth roughly 200,000 US dollars that secretly contained hidden authorization instructions. And these commands transferred withdrawal authority from Swissborg's legitimate controllers to attacker-controlled addresses across multiple stake accounts. The transaction appeared completely normal among the many daily staking operations. On the attack day, the hackers activated their planted permissions and drained over 190,000 SOL tokens in approximately 30 minutes. They split the stolen funds into two operations, moving 41 million US dollars worth of tokens to one wallet where it remains untouched, while using smaller amounts to test money laundering routes through multiple addresses and eventually depositing 100 SOL into BitGet exchange. Swissborg detected the unusual API activity within 30 minutes and immediately suspended their SOL staking program. The CEO announced full reimbursement to affected users from company reserves covering the entire loss, despite the breach occurring at their partner's infrastructure level. The staking partner Killin admitted to unauthorized access to a wallet used for staking operations and disabled their dashboard and APIs while investigating. The attack exposed a critical flaw where Killin's API granted permanent withdrawal permissions from what should have been temporary transactions. The incident shows how modern crypto platform depends on networks of third-party APIs and services, creating supply chain vulnerabilities where one partner security failure becomes everyone's problem. And here a nice quote: "The era of your partner's bug is your bankruptcy has begun." The next topic is about Nginx, also topic we covered in the load balancing lecture. It's the following article here. In August, Nginx announced built-in support for the ACME protocol through their official Nginx HTTP ACME module. And this allows Nginx to automatically obtain and renew SSL certificates from Let's Encrypt and other certificate authorities without requiring separate third-party tools. The new module is implemented in Rust and enables Nginx to join the other web servers like Traffic. Well, Traffic is not a web service, but Caddy, for example, and Apache that already have native ACME integration. And this means operators no longer need to manage separate ACME clients or manually handle certificate renewals for their Nginx deployments. Native ACME support provides more seamless integration compared to external certificate management tools. It reduces operational overhead since administrators don't have to configure, maintain, and troubleshoot additional software components. The automation handles certificate provisioning and renewal cycles without human intervention, and Nginx is one of the most widely deployed web servers and reverse proxy globally. And with this addition, a significant majority of web infrastructure can now handle SSL certificate management natively. This applies across deployment scales from home labs to enterprise Kubernetes ingress controllers, for example. Let's Encrypt reports that nearly 700 million websites currently use their certificate authority service, and the addition of native ACME support in major web servers advances their goal of encrypting more web traffic by making certificate management simpler and more reliable for operators. The integration represents a trend where core infrastructure software builds in security automation rather than requiring external tools. And this reduces complexity in distributed systems where certificate management has traditionally been a manual operation burden that scales poorly across large deployments. And the feedback shows mixed reactions to Nginx native ACME support. Some developers appreciate the convenience of having certificate management built in directly into the web server, eliminating the need for separate tools like Certbot and reducing operational complexity. However, others prefer the Unix philosophy of specialized tools, arguing that adding ACME functionality to every application creates unnecessary complexity and potential security risks when a dedicated certificate management tool could serve multiple services on the same system. I personally prefer the integrated approach, and I recently moved my website from Nginx to Caddy because of this automated certificate management. The last topic for today is about PayPal. It's the following article here. PayPal announced that cryptocurrency will be directly integrated into their peer-to-peer payment system, allowing users to send Bitcoin, Ethers, and PiUSD stablecoin through both PayPal and Venmo applications. The crypto functionality will work with PayPal's existing network and extend to other digital wallets worldwide that support cryptocurrencies and stablecoins. This integration represents PayPal's expansion beyond traditional fiat currencies transfers into blockchain-based assets. Users will be able to send crypto assets as easily as they currently send dollars using the same interface and payment flow within the PayPal ecosystem. The announcement lacks specific technical details about how the crypto transfer will work, whether they involve actual blockchain transactions or internal ledger movements, and what fees will apply. PayPal has previously offered crypto buying and selling, but kept those assets within their own system rather than enabling true blockchain transfers. But at least something is happening at PayPal with respect to cryptocurrencies. So that's it for this week. See you next week.